Okay, so we start with polynomial x cubed minus 3x squared minus x plus 3 divided by x plus 1, and we want to find the quotient and remainder. So it's you could do long division, or you could do the kind of the grid method that we've been working on. I'm going to do that because we've been doing that quite a lot. And so what is it that we're doing here? We're dividing x plus 1 into x cubed minus 3x squared minus x plus 3. So that is, I just need a reminder of that, don't I? X cubed minus 3x squared. Oh, I can't remember what I'm writing. Minus x plus 3. Okay, so that needs to be an x cubed. What do I multiply x by to get x cubed? It's x squared, which would give me a plus 1x squared down there. I'm supposed to have minus 3x squared though, so I'm going to have to take away another 4 to get down there. X times minus 4x gives me minus 4x squared. Minus 4 times plus 1, that's minus 4x down there. Supposed to have just minus one of them, so I'm going to have to add 3 x's in that space. X times 3. And 3 times 1 gives me 3, and I was supposed to have 3. So I've got a remainder of 0, and the question did clearly say find the quotient and remainder, so I'm going to have to state then the quotient is this thing on the top, and the remainder, don't leave it to chance that the person marking it will notice that you've ended up with a remainder of 0. The remainder is 0. So that's how I would do that. 3 marks. Hence find the 3 roots of the equation. Right, so what that means is that x cubed minus 3x squared minus x plus 3 is the same as x plus 1 times x squared minus 4x plus 3. And so I'm going to factorise that. It does factorise. What is it? X minus 1, x minus 3. And that's not enough, is it? Because that hasn't answered the question. The question said find the 3 roots. So the roots are x is minus 1, x is plus 1, and x is 3. They are the 3 roots of the equation. Right, now it gets interesting, because now it starts to do some stuff with this. The diagram shows the curve with equation there. This is a different equation. It's not that curve. We now have a different equation going on. X to the 4 minus 4x cubed minus 2x squared plus 12x plus 9. We're thinking, is it related? Show that the x coordinates of the stationary points on C are given by this equation that we spent the first part of the question solving. Well, how do you find stationary points? Stationary points are where dy by dx is equal to 0. So, when we come to do this for part 3, at stationary points, dy by dx equals 0. We were starting with y equals, I'm just going to copy it from here because I don't want to scroll up, x to the 4 minus 4x cubed minus 2x squared plus 12x plus 9. So dy by dx for that curve is 4x cubed minus 12x squared minus 4x plus 12. And it was the AS lunchtime support thing on Friday. I was making a big point about when you're finding stationary points, you must put stuff. You must show that you're putting this equal to 0. Don't leave it to be assumed. So, at the stationary points, 4x cubed minus 12x squared minus 4x plus 12 equals 0. That's almost what we wanted, but it's not quite there. And it's only at this point that I can divide through by the common factor of 4 to give me x cubed minus 3x squared minus x plus 3 is 0. as required. That was what we were looking for, wasn't it? Yeah. Now, there's quite a subtle little point here that quite a lot of students noticed that this was almost what they wanted, and by dividing by 4 they could get what they wanted. And if you do that in the wrong order, then it's just wrong. So you can't divide by 4 until you've put it equal to 0. Because if you divide this by 4, all you're getting is a quarter of dy by dx. So you must put it equal to 0 first, and then, because you can do the same thing to both sides of the equation, you can divide by 0 and get what you want. Right, now the final 4 marks. Use integration to find the exact area of the region enclosed by C and the x-axis. And what we're supposed to think at this point is we're supposed to pull together all of what we've learned so far in this question. So as the question's gone on, we've learned that the stationary points are the solutions of this equation. And the roots of that equation there were what we found in part 2. So the roots of that equation were x being -1, 1 and 3. So that point is -1. That point is x equals 1. That point is x equals 3. And so the area that we're looking for, enclosed by the curve and the x-axis, is the area between -1 and 3 underneath that curve. So we've got to do the integral. Finally, for part 4, the integral from -1 to 3 of this curve, x to the 4 minus 4x cubed minus 2x squared plus 12x plus 9, because that's what it's asked us to find the area underneath that curve. And so we've got a final integration question to deal with. Add 1 to the power, divide by the new power. I'm going to do this a little bit quicker because time's getting on. So 4x cubed over 4 is just going to give me x to the 4, isn't it? And 2x, that's 2x cubed over 3. 12x squared over 2, so that's 6x. 9x there. That's quite a lot of stuff going on there. We're going to sub in the values. 3 to 5 would be, is that what we're doing? Yes, 200 stuff, 43 minus 81 minus 50, oh hang on, 18 plus 18 plus 27, take away minus a fifth, minus 1, plus 2/3, minus 6. Hang on, that should be a squared, shouldn't it? Sorry about that, that's a squared. I missed that. So that's 6 times 9, so that's 18 that I wrote there is actually a 54. Sorry. Is that right? Is that right now? And so here, this makes this a, where was it up to? That makes that a plus 6 and that a minus 9. And if you pull that together, I hope I've got that one right. Is that the same as I wrote when I did it? It is exactly the same. And it gave me 512 over 15 as being my answer, which was the answer they were looking for. They needed it exactly. The question did say find the exact area, there it is. So they did need that fraction at the end of it. There we go, we've done it. That's maths.